Ever wondered what happens between the engine and the wheels? There's a critical piece of machinery sitting right in the middle called the transmission. Without it, your car's engine would spin like crazy, but you'd barely move, or you'd stall out every time you tried to start. Let's find out how it works. Here's the core problem a transmission solves. Your car engine works best when it spins within a certain range, usually between about 1,000 and 6,000 RPM or revolutions per minute. But your wheels need to spin at totally different speeds depending on the situation. Crawling through a parking lot, merging onto the highway at 65 miles per hour? Those are very different demands. The transmission bridges that gap. The secret ingredient is gears. And if you've ever ridden a multi-speed bicycle, you already understand the basic concept. When you're starting up a steep hill, you shift to a low gear. It's easier to pedal, but you don't go very fast. Once you're cruising on flat ground, you shift to a high gear. Each pedal stroke takes you much farther. Car transmissions work on the exact same principle. So how do gears actually work? It all comes down to a trade-off between speed and torque. Torque is rotational force, basically the twisting power that gets your wheels turning. When a small gear meshes with and drives a larger gear, the larger gear spins slower, but with more torque. Flip it around. A large gear driving a small one, and you get more speed, but less torque. This trade-off is the heart of every transmission. Let's look inside a manual transmission, the kind with a stick shift. Inside the housing, you'll find sets of gears arranged on two parallel shafts. The input shaft connected to the engine and the output shaft connected to the wheels. When you move the gear stick, you're actually sliding a metal collar called a synchronizer that locks a specific pair of gears together. Each pair gives you a different gear ratio, a different trade-off between torque and speed. First gear has the largest gear ratio, meaning it gives you tons of torque to overcome inertia and get a heavy car moving from a dead stop. But you can't stay in first gear forever because the engine would hit its limit quickly, so you shift up. Second gear gives a little less torque but more speed. Third, fourth, fifth. Each successive gear reduces the torque multiplication but lets you go faster. It's like climbing a staircase of speed. But wait, there's a problem. You can't just jam gears together while the engine and transmission shafts are spinning at different speeds. That would grind metal and destroy everything. That's where the clutch comes in. When you press the clutch pedal, it physically separates the engine's spinning flywheel from the transmission's input shaft. This brief disconnection gives you a window to slide gears into place. Release the clutch, and power flows again. Now let's talk about automatic transmissions, which is what most cars on the road use today. With an automatic, there's no clutch pedal and no gear stick. The car shifts gears for you. Instead of a manual clutch, automatics use a genius fluid coupling device called a torque converter. And instead of gears on parallel shafts, they use an incredibly clever arrangement called planetary gear sets. Let's break both of those down. A torque converter looks like a big metal donut, and it's filled with transmission fluid. Inside are two main fan-like components: the impeller, which is connected to the engine, and the turbine, connected to the transmission. When the engine spins the impeller, it flings fluid outward into the turbine, making it spin too. It's like pointing a powerful fan at a pinwheel. No physical contact needed. This lets your car sit at a stoplight with the engine running without stalling, because the fluid coupling can slip. The real magic of an automatic transmission is the planetary gear set. Picture this: a sun gear sits in the center. Around it, several smaller planet gears orbit on a carrier, kind of like planets around a star. And wrapping around the outside is a ring gear with teeth on the inside. Here's the brilliant part. By using clutches and bands to lock or release different components, the transmission can produce different gear ratios without ever moving gears in or out of mesh. Lock the ring gear and you get one ratio. Lock the sun gear and you get another. It's elegant engineering. Modern cars have pushed transmission technology even further. Many newer cars use a CVT, a continuously variable transmission. Instead of fixed gears, a CVT uses a flexible belt running between two cone-shaped pulleys. By changing the width of each pulley, the ratio changes smoothly and continuously. There are no distinct gears, just seamless acceleration. Other cars use dual clutch transmissions, which are basically automated manuals, with 2 clutches that can pre-select the next gear for lightning-fast shifts. The engineering keeps getting more creative. So the next time you're riding in a car and feel that subtle shift as it picks up speed, you'll know exactly what's happening. Inside that metal housing, gears are swapping torque for speed, a clutch or torque converter is managing the connection, and brilliant engineering is making it all happen seamlessly. Whether it's a manual, automatic, or CVT, the mission is the same. Turn engine spin into motion at the wheels, at just the right ratio. Pretty amazing for a box of spinning metal, right? Stay curious and keep asking how things work.